Hello, Science 20. Today I want to keep building on this redox reactions and these chemical reactions that we're trying to work through. I'll try to make this video short, but I want to teach you some valuable skills to work through as we're working through these lessons about reduction oxidation. Hopefully we've been practicing building these reactions and balancing, and hopefully we're ready for single replacement reactions, and we're going to keep working with this. Remember, it's an element plus a compound. They form and then they rearrange to make a new element and then a new compound. Typically what we're going to see is we have two metals in there and we're going to swap the metals. It doesn't always have to be the metal and the metal swapping. It can be the anions or the negative ions, but most times we're going to be seeing metals, those positive cations, swapping places. So here we have silver nitrate solution reacting with solid zinc to produce zinc nitrate solution and solid silver. We're going to have 4 steps. Write out a balanced chemical equation, write all the species before and after, and then we're going to see if an oxidation or a reduction has actually occurred. So if you would like to try and practice taking this and creating a balanced chemical equation, please do so now. So from our balanced chemical reaction that we have, we should have gotten this. Things I want to draw attention to is when we're looking at the charges of the metals, because silver has a +1 charge, nitrate has a 1- charge, so that's easy to put together. Zinc, when we rearrange our cations, zinc has a 2+ charge. And so you see we've added the nitrate with the brackets 2, and then we've had to balance. Step 2, all the species before the reaction. What I mean by this is I want to look at each individual ion. And that's what I see here. I have Ag+, I have NO3 with a minus, and then I have zinc. Because it's solid and it's a metal, it's just going to carry a charge of 0. Next, we write all the species after the reaction. Now you'll see is zinc and nitrate are our new ionic compound, and silver has become the solid. And you see what I've done with the charges. So on silver, the charges become 0. It was positive and it's become 0. Zinc was 0 and it has become positive. Pause it here again if you think you can identify the reduction or the oxidation. So what we remember is there is Leo and Ger. So if that's the helpful, remember which one is losing the electrons or gaining the electrons. Hopefully we saw that zinc, it lost an electron. To go from 0 to a positive, it would have had to give up an electron. It lost this electron here. At the same time, the silver over here would have gained the electron, and it went from positive to 0. So that positive, it reduced its charge, and that's going to be the biggest giveaway, is which one is reducing its charge. Zinc to a positive gained charge. Silver to a positive to a 0, it reduced its charge and it gained the electron. And you see what's happening from the beginning to what's happening at the end. Now, with that reaction, I have this term, because what happened to the nitrate? Well, nothing. We have this term. It's just called a spectator ion. And so from that one, we're just determining that it does nothing for our oxidation reduction reaction, but it's the negative part. It's the thing that just is watching and it just remains the ion. Wouldn't say it's useless, but it's spectating and it allows this reaction to actually occur, because without it, we couldn't actually flow electrons through. Before we get on to more skill base and some practice questions, I wanted to go over 2 more terms. We're going to have this term. Whatever substance is being reduced, so from that last example when we had that Ger, right, we are going to call it an oxidizing agent because it allows oxidation to occur. It helps oxidation occur. And then on the opposite side, whatever is being oxidized is called the reducing agent. And so labeling which one is going through reduction or oxidation, we can label that. Whichever is Leo, whichever is Gur, we can do that. And then you just have to remember when we're talking about the agent, they're the ones that support the opposite reaction. So you just have to think these terms are flipped in the opposite way. With these new terms, we want to make sure we're getting them in the right order. So when we talk about reducing agents and oxidizing agents, we need to make sure we're understanding it is the substance being oxidized or it's going through reduction. And this is going to be the more common way to go about it. It's just helpful to introduce oxidation reduction there, but a lot of times we're going to be talking about the species as the one going through reduction or the reducing agent, and then the oxidizing agent. And then of course any spectator ions. So first things first, when we go through it, we want to actually look at what species, or we're kind of looking at each individual part, and we're looking at the charges. So when we see zinc, it has 0. Hydrogen, it has a positive charge. Chlorine has the negative charge. Zinc now has a 2+ charge, and chlorine has the negative. If you're helpful and looking up with a periodic table, definitely helps to look and have these species up there if you want. And now that hydrogen's all on its own, you can see that it has a 0 charge on it. What we're going to do now is look at each one before and after. So for zinc, we're going to pair up zinc, and I'm going to draw a line to connect here to the zinc. And I want to see what's happening with the charges. What is happening with electrons? How do you go from 0 to 2+? Well, to go up in positive charge, you would have to lose 2 electrons. So these 2 electrons are getting lost. We're going to call it losing electrons. And remember, it is Leo, so it's going through oxidation. And the opposite agent is the reducing agent, Ra. Now we're going to look at the other positive, hydrogen. Hopefully it agrees with it. So when we draw up to hydrogen, we see that it's going from a positive to a 0. So it's reducing its charge. It's going from positive to 0. It's dropping down. It's reducing its charge. What it is doing, it is gaining electrons. So it is gaining electrons. We call this reduction, R. And we lost 2 initially, but if we look here, there is 2 hydrogen. Here, there is 2 hydrogen. So essentially, each hydrogen has taken an electron, and it has gained 2 electrons, and we are going to call this the OA, the oxidizing agent. This one is like a travel agent. It allows the other species to go through oxidation. Just like up here, reducing agent allows reduction to happen, and it helps reduction actually happen. So a travel agent doesn't travel for you. They don't travel with you. No, they help you travel. So you can think of this as the reducing agent is the electron travel agent. It helps reduction happen. The oxidizing agent helps oxidation actually happen. And then finally, we can see the thing we didn't even touch is right here. The chlorine and the chlorine would be the spectator ion. Now, what I would like you to do, try and practice these examples right here. I'll erase them out, pause the video, and if you can, please try and practice on your own. Now we do have this thing called an activity series, and it's an activity series for the metals we're only going to look at in Science 20. It is very helpful. There's a video clip if you need to, and I'll post the link, but I have a picture in the next slide. And so remember that when we look at things, and here's another example I want you to practice, there is 2 half reactions that we're going to look at. And right away we can see oxygen and oxygen is there. It's ion, that's my spectator. we're going to focus on these two half reactions. So there's this Hg and there's this cadmium going through. And we can see it's going from the positive to a 0, and it's going from the 0 to the positive. And we can see which one is reducing charge, Hg. So here is my gaining electrons, my Ger. Hopefully we practiced the last one. Here is my Leo. And now we're going to look at this activity series to help us figure out what exactly is happening and how to be a useful tool for us. This table, as you can see right here, is the activity series. And so it's always referred to as the activity series or the activity series for metals. But we're going to be using this to really help and be a tool so we don't have to memorize everything and how do we know if a reaction actually goes forward. So if we looked here, we can see here was my Hg molecule as an ion, and then you can see, as we said, it was a reduction, and everything on here is listed as a reduction reaction, and it's all this direction. So it's all going from ions to our solids. However, how does that work? For cadmium, we had cadmium as our we had that as our product on the other side. Well, if you read it backwards, where we go from the solid, we can reverse the arrow, and now this tells us the oxidation, and this is the oxidation reaction. So if we just go backwards on it, it is an oxidation reaction. And we see that here. And we can see that the Hg up top, right up here, it is the reduction half reactions, and we see that labeled right at the top. So they're all reduction reactions, but we're choosing two, and we just have to see. Here is our before, here was our before, and then here was our after over here. And we kind of have them on opposite sides. We're going to talk about why that's important. So what we're going to use this activity series for is when we're looking at different substances on the top or on the bottom. And so when we write out the species present and when we see them all separated out, we want to see if the SOA is above the SRA. Well, what does that mean? This is the strongest oxidizing agent is above the strongest reducing agent. And so remember, on that last example, we saw it was reduction and it had that Hg was up there. It went through reduction. It was my Ger. It was my oxidizing agent. It was higher than this one, which was my cadmium, and it was lower and it went through oxidation and it was a reducing agent, and it was my strongest reducing agent. This means if we were to do this example in the chemistry lab and we had that exact same reaction happening, it would just start going and it would just happen and it would just react. If the opposite is true, if the cadmium was higher on that list and the Hg was lower on the list, then the reaction would not happen, and we call this non-spontaneous. And this will become important later when we're talking about batteries. But it depends if the ion is at the top end and higher than the solid. And we're going to talk about how this is important to see if it's spontaneous or not, and we'll go through some examples. From our example, we can see this spontaneous reaction. So if your SOA is up here, and it even has a little sidebar, is the strongest oxidizing agent is up here, and it goes through a reduction reaction, and it goes this direction, and it is higher than your strongest reducing agent over here, or your just reducing agent, because we're only dealing with two. So if we're going this way, and it goes through this direction like this, that's perfect, because what I like to show is you have little arrows on the side and there's arrows that go down, and if it connects like this, because you have these arrows that are going strength of oxidizing agent, strength of reducing agent on your side of your activity series that you're looking at, you'll see it makes a circle. However, on the non-spontaneous, we still have these down arrows, and so when this arrow and this arrow come up to it, it doesn't complete it because, well, it doesn't connect to it. This down arrow is going this way, and so when I go this direction and I have these down arrows going this way and my reaction goes this way, it flows and it goes down. If my reaction is going this way, it flows and it goes up. These arrows are now not connecting to each other and they're not completing it, not like the spontaneous above. So the above one is like a circuit and we're completing the circuit. Below, we have a break in the circuit and they're not connected. This would be a non-spontaneous reaction, meaning we need to add electricity for this reaction to actually occur. So what we're doing today, right now, I want you to identify half reactions and then tell me, will this reaction actually happen or not? What you need right off the bat, I'm just going to go through A, but you can pause it here or kind of rewind to get it. This is taken right out of the textbook, but when I pop up my activity series, hopefully you have it. Like I said, you can just back up a little bit and have this table part to help you once you kind of go through it. What you see here is when we're going through it, I want to see what is the reaction and what is happening at the start. And we don't even need to really complete it. We can read this and read our table to help us out. So here I have a brick of gold placed into a silver nitrate solution. So what's actually going to happen is I have my gold here, and then I have my silver ion over here. What we see there is I have my silver ion over there. If I wanted this reaction to go through, and I want my silver ion to go this direction, my reaction, my reduction half reaction, would just be that. I'm already given my silver. So my reduction half reaction that I can list out is Ag plus, and then I go plus 1 electron, and I just write it exactly from the table that I'm given. Ag with a 0 charge. It's solid now. There we go. There's my reduction half reaction. I don't need to complete the full reaction. I have this table to help me out. Now, if I want gold solid to go the other direction because, well, I can't have it lose more electrons. So if I want this to happen and to go from Au, so gold solid, and I'm going to add in a 0 charge, it would have to lose electrons, and that's the way we show it here, where I lose 3 electrons plus Au 3 plus. Perfect. And so there we go. And now, what reaction happens first? Is my oxidation reaction this one? Remember, this is oxidation reaction, so this would be my reducing agent. This would be my reduction reaction, which is my oxidizing agent. So which one appears first? It's my Ra, my reducing agent. Because my strongest reducing agent is at the top, right here. This one is above the other. The reaction type would be non-spontaneous. This means this reaction will not happen unless I do something like add electricity into it. Okay, and so when we drew those arrows, remember there's this up arrow going on the side of yours. There is a down arrow over here. My arrow, when it goes through, hits this up arrow, it goes this way. This arrow goes through, hits the down arrow, It is not connecting the arrows. It's not completing the circuit. It's not spontaneous. This is a non-spontaneous reaction. So now please try and do the other examples, trying to write out and figure out the half reactions and seeing if you can figure out which one is higher or lower on the activity series. And then lastly, pause here and try some more examples. This takes a lot of practice getting the terminology set, and hopefully when we come back on Tuesday, I can help clarify some of these activity series questions as well. So please practice with these questions and take care and have a great day, everyone.